Hey everyone, and welcome to This Explainer. Today, we're unpacking a topic that goes far, far beyond your standard government policy. We are looking at the literal, invisible backbone of modern geopolitics, economic security, and honestly, our very technological survival.
I want you to picture a scenario for a second. Imagine modern military operations. We're talking precision-guided missiles, stealth fighter jets, advanced radar, just grinding to an absolute halt. No way to operate. Now picture the entire green economy, from electric vehicles to massive wind turbines, completely paralyzed. This isn't some dystopian science fiction plot. This is the very real vulnerability facing nations today, and it's all caused by a massive hidden dependency.
The key to that terrifying dependency actually comes down to one highly specific number: 17. We aren't talking about abstract economic theories here. We're talking about 17 physical, tangible metallic elements pulled straight from the Earth that literally power the future.
These are what we call rare earth elements, or REEs. Before we get into the complex geopolitics, let's establish a really clear mental model. Rare earth elements are 17 specific metallic elements that possess incredibly unique magnetic, heat-resistant, and conductive properties. Without them, the advanced technologies, clean energy transitions, and modern defense systems of the 21st century simply cannot exist. Period. Okay, let's dive into this and look at our strategic roadmap. First, we'll tackle the rare earth dilemma. Second, unpacking the NCMM strategy. Third, building the supply chain. Fourth, strategic and defense impacts. Fifth, hidden bottlenecks. And sixth, our final revision and takeaways. Part 1. The rare earth dilemma, the geopolitical trigger. Before we can even begin to understand the solution, we have to look at the massive global vulnerability that triggered it. Now, what's really interesting to see here is the stark, undeniable contrast at play. India actually possesses some of the world's largest natural reserves of these vital elements right beneath its own soil. But the dangerous reality? Another nation holds an absolute monopoly. China currently controls roughly 60% of global production, and an astounding 85 to 92% of global processing capacity. That extreme concentration creates a profound strategic vulnerability, forcing a major policy shift. Moving to Part 2, unpacking the NCCM strategy, the engineered system. So, that policy shift takes the form of the National Critical Mineral Mission launched in 2025. You shouldn't think of this as just a simple scheme. It's a highly engineered system designed to build a resilient, shock-proof domestic supply chain. And a system like this requires immense capital. Think of this 16,300 crore rupee budget as the literal price of strategic autonomy. Notice how the funds are carved up. A massive slice, 7,350 crores, goes directly to a production-linked incentive scheme specifically for rare earth magnets. This targets the most critical manufacturing gap. Another 500 crores is dedicated entirely to stockpiling, which basically creates a 2-month strategic reserve to shield the nation from sudden global supply chain shocks. The rest goes to supporting broader mission initiatives.
Let's move to Part 3 and see how this builds out, building the supply chain, from ground to product.
We're looking at a complete overhaul of how materials move from the Earth all the way to the end user. This is the chronological pipeline of the mission. It starts upstream with exploration. Over 100 critical mineral blocks are being auctioned, and the Geological Survey of India is aggressively pursuing 1,200 exploration projects by 2030. Step 2 is mining, where regulatory reforms are streamlining licensing to bring in private sector expertise. Step 3 moves midstream to processing, which means establishing dedicated mineral parks. And finally, Step 4 closes the loop with recycling, a dedicated 1,500 crore scheme to recover these precious elements from end-of-life electronics. It's a fully interconnected circular system. Part 4. Strategic and defense impacts, powering the future. So how do these acquired materials actually translate into national power? Well, the source material gives us this incredibly powerful metaphor. Rare earth elements are, quote, the specialized fuel cells and sophisticated armor of the future economy and military. Think about that. Just as the 20th century relied heavily on steel and oil, the 21st century relies on these specific elements to provide capabilities that conventional materials just cannot replicate. And this brilliantly illustrates exactly how that plays out across different sectors. Look at green energy. It's the intense magnetic strength required to spin massive wind turbines and power electric vehicles. But cross over to defense, and those exact same properties are what enable the highly precise electronic control in missile guidance systems. They're the absolute core of radar, sonar, satellite communications, and even the physical structures of advanced fighter jets. Economic innovation and national security are completely 100% intertwined here. Which brings us to Part 5. Hidden bottlenecks and challenges, the rare earth dilemma.
Now, you might be wondering, why is this so hard? Well, achieving strategic autonomy is fraught with severe obstacles. This is the dark side of extraction. Getting these elements out of the ground is environmentally brutal. The process generates massive amounts of toxic waste that threatens to contaminate air, water, and soil. Even more critically, rare earth ores are frequently laced with naturally occurring radioactive elements like thorium and uranium. This creates grave health hazards, risks severe ecological damage, and triggers incredibly strict regulatory hurdles, particularly around coastal zones.
What this does is create an intensely difficult regulatory balancing act. On one hand, you have massive ecological concerns requiring strict clearances, detailed impact assessments, and highly controlled radioactive waste disposal. But on the other hand, you have urgent economic needs. When foreign export curbs hit, global REE prices can surge by 35 to 40% almost overnight, driving up input costs for vital electronics by 20 to 25%. Policymakers are completely caught between protecting the environment and reacting to devastating market instability.
And resolving this? It takes time, a lot of it. To put that into perspective, 15 years is the estimated gestation period required before the massive capital investments in integrated mining and processing infrastructure actually yield substantial self-reliance. This is a long-term game that will severely test investor patience and political will.
So the crucial point to understand here is the structural weakness in the value chain. Right now, India has upstream capabilities, meaning it can dig the minerals out of the earth and do the initial oxide separation. But there's a massive downstream gap. Think about it. Digging the minerals out of the ground means absolutely nothing if you lack the industrial-scale facilities to turn them into advanced alloys, permanent magnets, and finished high-tech components. That incompleteness is the exact vulnerability the new multi-thousand crore PLI scheme is desperately trying to fix.
Finally, Part 6. Final revision and takeaways. Concept mastery.
Let's lock all this in. Here is your rapid 30-second final recap of the facts you absolutely need to remember. The trigger: a massive geopolitical vulnerability due to an 85 to 92% foreign processing monopoly. The response: the 16,300 crore national critical mineral mission. The goal: absolute strategic autonomy to fuel the green transition and advanced defense systems. The gap: the critical lack of downstream manufacturing, specifically for permanent magnets. And the timeline: a grueling 15-year gestation period to build this from scratch.
Which leaves us with the ultimate, incredibly complex policy puzzle to consider. As the demand for clean energy and advanced defense technology skyrockets globally, how exactly will a nation balance the immense radioactive ecological risks of extraction with this urgent 15-year race for absolute strategic autonomy? It's a tough road ahead, and it's one that will for sure define the technological hierarchy of the coming decades. Thanks for joining me on this explainer. Keep asking the big questions, and I'll catch you next time.